Hi, this is Mrs. Shvach, and today's lesson is from Chapter 4, Section 1. Our objective today is to recognize congruent figures and their corresponding parts. In fact, the whole Chapter 4 is on congruent figures. When we talk about congruent polygons or congruent figures, we're actually talking about polygons that have the same shape and the same size. If they're the same shape and the same size, they also have corresponding parts congruent. So to have two figures that are congruent, you have to have the same shape and same size, and you have to have corresponding parts equal. Another way to look at congruent polygons is you can slide the polygon from one area to another and it be the same polygon. You can flip a polygon and you'll start and end with the same polygon, and you can also rotate or turn a polygon from where you start to end. It's the same polygon. Those three, if I can do those three, slide, flip, turn, / rotate, then those figures are congruent. I like to use this picture to demonstrate the difference between congruent and similar, because many students get these two mixed up. When you have a congruent set of polygons, you start and end with the same shape and the same size. When you have similar polygons, you start with the same shape, but clearly the sizes are different. So in this example, in the bottom, these two figures are similar, not congruent. You start with the same shape, but not the same size. In this first example, we're given that TJD, triangle TJG, is congruent to triangle RCF. Okay, from that statement, that means when I say two triangles are congruent, that means they're the same shape and they're the same size. Now, once I know they're congruent, I can also list what's called their corresponding parts. So in this case, since I have a triangle, I'm going to list three sides of one that are corresponding congruent to three sides of another. And then I'm also going to list the three angles in one that are congruent to the three angles in the other triangle. Now in the diagram, you actually have to rotate and flip the triangle so that they match. So what I tell students to do is not necessarily look at the figure, but actually just use the statement above. So in that statement above, if you look at the angles, I'm going to list the three corresponding angles in one triangle that are congruent to the three corresponding angles of the other triangle. So I'm actually going to start with the first one. So in this case, I have angle T is congruent to angle R. And then I do the second set of numbers or letters. Angle J is congruent to angle C. And in the third case, I do the last set of angles. Angle D is congruent to angle F. So if the picture confuses you because I have to rotate this triangle and flip it so that T matches with R, J matches with C, and D matches with F, if the diagram confuses you, just use the statement listed above. So those are the three sets of angles that in one triangle correspond to the other triangle, and they're consequently congruent. Now, with angles, I can do the same with sides, because there's three sides. So with sides, again, I'm going back to the actual statement above rather than the diagram because I don't want to mess up. So I'm going to use, in the diagram, I'm going to use side TJ is congruent to side RC, and that's how I write it. So I took the first two with the first two. Then I'm going to take the second two JD is congruent to the second two on the other side, CF, and then the last side would be the first and the third. TD is congruent to RF. So in this example, I give you two triangles that are congruent. Because they are congruent, you can list their congruent corresponding parts. So down below, I've listed angles and I've listed sides. So I should have 3 angles and 3 pairs of sides. And really all I need is this statement right here to match everything up. So if the drawing confuses you, do not use the diagram. In the second example, you're given triangle LMC is congruent to triangle BJK. Again, you actually have to think about the fact that these two triangles are a reflection upon each other. So in this case, L and B correspond to each other. So these two are corresponding parts in this congruent triangle. M and J, so those two are corresponding parts in the two congruent triangles. And then C and K are corresponding parts. So when I look at each of these examples, I just have to line those 3 up. L's got to go with B, M has to go with J, and C's got to go with K. So in the first example, I say LC is congruent to which segment in the second triangle? Well, if I look, L is congruent to B, and C is congruent to K, so my answer is going to be BK. So in the fourth example, we're looking at segment KJ, which is a segment in the second triangle, and it's in position 3 and 2. So we want to look at the first triangle in position 3 and 2. So my answer is going to be segment CM. And number 5, I'm looking at JB, which is in the second triangle, which is in positions 2 and 1. So I go to the first triangle and I look up positions 2 and 1, which would be M and L. In number 6, we're looking at angle L, and we want to know what's congruent to L. L is in the first position in the first triangle. So the first position in the second triangle is angle B. So L is congruent to B. In number 7, we're looking at angle K, which is the third angle, third position in the second triangle. So the third angle in the first triangle is angle C. So angle K is congruent to angle C. Number 8 asks for angle M, which is the second position in the first triangle. So the second position in the second triangle would be J. So angle M is congruent to angle J. So for number 9, I'm looking at triangle CML. So if I line everything up with the angles in the second triangle, for number 9, I'm going to have triangle KJB. For number 10, I have to line up my triangles so they're congruent to KBJ. So my answer for number 10 is going to be triangle CLM. For number 11, if I line up my triangles that are congruent to MLC, I've got J, B, K. And for number 12, if I line up my triangles to J, K, B, I've got M, C, L. In example number 3, I took right from the book. They showed a picture of a space shuttle, and these pentagons down below are the fins, part of the fins on that space shuttle. So basically the question asks, find the measure of angle B. which is this angle in the second fin. So I have pentagon C, A, P, S, E, and that would be congruent to pentagon R, W, B, D, T. So here's what I can do. I know that angle A is a right angle. I know angle C is 132. So if C is 132, then W is 132. I know P is a right angle, so I know T is a right angle. I know S is 88, so I can say D is 88. Okay, so I have 4 angles in a pentagon. I need to find the 5th angle and then subtract it from the total angles in a pentagon. Well, I know from chapter 3 that the sum of the angles in a pentagon are going to be 180 times n minus 2, n being the number of sides. So since there's 5 sides in a pentagon, the total for the sum of all the angles in my pentagon is going to be 540. So once I know 540, I can add up the 4 that I already know and subtract those 4 from 540, and that'll give me my angle B that I'm looking for. When I add 132, 90, 90, and 88, I get 400. Now I have to take that 400 and subtract it from 540, and that will give me my angle. That will give me my measurement of the missing angle. So that measurement of the missing angle is 140. So the measure of angle B equals 140 degrees. In the fourth example, they give me a statement: triangle DEF is congruent to triangle LMN. The statement says they are congruent, so that means they're the same shape and same size. I know D lines up with L, I know E lines up with M, and I know F lines up with N. So really you're kind of rotating this triangle in this direction so that D and L match up, E and M match up, and F and N match up. Okay, now I want to figure out which statement listed below, A, B, C, or D, is correct. So we just got to go through each one and see which one's true or false. So in answer number A, it says that segment DE is congruent to LN. Well, if I look on top, that's DE, so that's the first 2. LN is the first and the third. So these don't line up correctly, so my answer is not A. Can't be. B says angle N is congruent to angle F. Well, F is the third one, and N is the third one. So that does look correct, but let's check the rest of the 2 to make sure C and D are also false. So that would indicate our answer is B. Okay, C says FE is congruent to NL. Well, FE is the third and the second one, so that would have to mean N and M are congruent, and they use N and L, so that's false. Okay, then in the fourth example in D, it says angle M is congruent to angle F. Well, M is the second one. F is not the second one in the first triangle, so that doesn't line up either. So my answer is B. N and F are congruent. That's the only choice out of 4 that's correct. The last concept in this lesson talks about a theorem that deals with 2 triangles and having congruent angles. The theorem says this: if 2 angles of one triangle are congruent to 2 angles of another, then the third angles of those 2 triangles have to be equal. So in this case, in triangle ABC, you have A congruent to angle D in DEF. You have angle B congruent to angle E. So if those 2 angles are congruent to each other, then you have to have those third angles congruent. So if A is congruent to D and B is congruent to E, then you have to have C congruent to F. So in this lesson, we talked about congruent figures, whether we have triangles, pentagons, quadrilaterals, hexagons, heptagons, it doesn't matter. If you have congruent polygons, you have corresponding parts. Now, this essential question at the end of this lesson asks, how many pairs of corresponding parts are there in two congruent pentagons? We just had an example of two congruent pentagons when we talked about the fins of the shuttle. So when you have two congruent pentagons, pentagon means 5 sides. So if I'm going to have 5 sides to my shape and I have 2 of them that are congruent, then I'm going to have 5 angles that are congruent from one pentagon to the next pentagon, and I'm also going to have 5 sides. Since I have 5 sides of my pentagon, I'm going to have 5 angles that are congruent, 5 pairs of angles that are congruent, and I'm going to have 5 sides, 5 pairs of sides that are going to be congruent.